Good morning, all. This is the second half and our last video on exponential growth and decay. When it comes to exponential growth and decay, again, the previous section we went through the solving. We're just going to look at some of the graphs and do a little bit more solving today. We already spent time dealing with exponential functions and how the graphs will look. So we don't really need to go too much further here, but I just want you to understand like how the two different graphs will look. When it comes to exponential growth, this is when we have our a, b to the x, and again when it's a growth, b is the power. When it comes to decay, we have the same thing. Again, the formula doesn't change. A, b to the x. But when it's decay, your b is less than 1. So basically, if it's exponential growth, it's going to, I don't want to say it's always going to go to 0, but unless there's if it's just like 7 to the x, with no coefficient, constant, no a in front of it, or I shouldn't say no a, but a is 1. Because if there's nothing written there, then it's understood that it's a 1. But if a is 1, then it's always going to pass through this point 0, 1, because if you take anything to the 0 power, it's going to be 1. So if we put 0 in for x, we should always get 1. But again, if we had something like 2 times 7 to the x, then in that case it'll be 2 times 1. So it could change and it wouldn't be 1. But for the most part, a lot of the graphs will be 1. And that's going to be whether it's a decay situation or growth. But when it is growth, again, the idea here is, again, you always, whenever you don't know what's going on with the graph, you want to look at some negative, you want to look at some positive, and you want to look at, normally just pick these basic values just to get an idea of what both sides of the graph will look like. So again, let's say I have that graph, a basic one, y equals 7 to the x. Again, x is the exponent, so it'll be 7 to the negative first power. Let me leave a column here. All right, so it'll be 7 to the negative 1. Whenever we have a negative exponent, remember that you have to rewrite it as 1 over 7 to the first. To get rid of negative exponents, you put them in the denominator. So this is just going to be an answer of 1/7. When you have 7 to the negative second, that'll be 1 over 7 squared. And we know 7 squared is 49, so it'll be 1 over 49. Sorry, let me pick a thinner point because that's a little crazy looking. 7 to the 0. Again, we've already alluded to, anything to the 0 power is 1. 7 to the first power is 7. 7 to the second power is 49. Excuse me, I'm sorry. These yawns, as soon as I start recording, are so ridiculous. All right, so then you would plot the points. Again, you would have the point 0, 1. Point there. You'd have the point 0, 1. Then you would have the point 1, 7, which would be like someplace here. Then you have 2, 49, which would be someplace here. Obviously, this is a bigger number, so both curves drastic depending on like how large, the number is to start. And then, and then on the negative side, what would start to happen is that you would have your 1/7. So it'll be negative 1 and 1/7. That's below 1. Negative 1 and 1/49. This would never quite cross the x. never become a negative. It'll be a really, really, really small decimal, but it would never become negative. So it will just hug that line all the way down. Hover right above that line. Never touch the x-axis. Wouldn't quite become 0, and it wouldn't cross it. The only reason you would see an exponential graph cross the x-axis when we're talking about exponential growth would be if there was like a, like a -2 or something there, and that would like shift your whole graph down 2 or something. But there would still be an asymptote, a horizontal asymptote, etc. Anyway, and then when it comes to decay, it's pretty much the same thing, just reversed. And the reason for that is because when it's decay, this number that's going to the power is less than 1. So when we say less than 1, we don't mean, it could be negative, but we don't mean necessarily, a negative. We just mean that value inside of here is between, because we're talking about decay, remember it has to be greater than 0. So you shouldn't be, with exponential functions, period, that can happen. But when it comes to decay and growth, that b value should be greater than 0 at all times. Anyway, so for this decay, what's going to happen, again, if we just think about it with a quick table, if we have, this is a half here. I should have used the 2 over here, but I don't know what I was thinking. So if I have a half to the x power, I have my x, I have my y. Again, x is the exponent, so I'm going to go with the same. I'm going to start with -2 this time. I should have done that before. And then I have +1 and 2. Excuse me. All right, and I'm going to take this to the -2nd. Now, again, you could just do these in your calculator and just do 1/2 to the -2nd, and you'll get the correct answer that way. But I just want to show you guys why this is going to look different from the growth, which is going up, from left to right. It's growing, the value is increasing, versus with decay, you start at your highest point and you're just consistently decreasing all the way down. With growth, you're starting and you're just constantly going up. So when it comes to this, if we have a -2, it's going to be 1/2 to the -2. Essentially, you're like distributing the exponent, so it becomes 1 to the -2 over 2 to the -2. Then negative exponents have to switch spots because they can't be negative. So it becomes 2 squared over 1 squared. 2 squared is 4, and 1. Excuse me. So this answer is going to end up being 4. If we do a -1, you're going to end up getting 2. Again, you can just plug it in your calculator. You don't have to do it by hand. I'm just trying to show you why it's getting bigger because of that negative exponent making these switch spaces. Anything to the 0 power is 1. So that's going to still be 1 there. And then we have 1. So 1/2 to the first power is a half. And 1/2 to the second power. Again, we distribute the exponent, so this becomes 1 over 4. So if we go back and then we plot these points, it would be, we know we have 0, 1, so that's the first point there. Then you would have 1.5, 2 of 4.25. And on this side, they're actually getting bigger because we have -1, 2, -2, 4. All right. So basically that's the process, and that's what we should be looking for. So I have a few sample graphs here. We'll do about maybe 2 or 3 of them just to give you some idea, and then we'll just do some brief answers. Oh, and also with decay, same thing. Our graph is going to hover right above that x-axis. Now, you will see some when we're doing the graphs where they are inverted, and by inverted, that means you might see some where there's like a -1 in front. So let's say we have -1/2 to the x. If we had -1/2 to the x, and all of this stuff would be now down here looking like that. It's like flipping the graph. And the same thing over here, if this happened, it would be like this, flipping the graph. If there was a y equals -2 to the x. So just keep that in mind that they can look slightly different when it comes to the growth and decay graphs. But those are really like more exponential graphs. And when it comes to growth and decay, they're pretty much going to take on this look. All right, so here are a few graphs. We just did the half x for that example, so I'm not even going to bother with this one. So we'll do this 3 to the x. So again, you want to incorporate a table. You don't have to show that middle row for the table, but you should have a table, and you should have the values that you plugged in. Since it's 3, I'm just going to go, again, you don't want to pick like 4, 5, and 6, because if you think about it, like 3 to the 4th power would be it's 81, so it would be something you don't want to graph. So you want to keep your numbers low for what you're plugging in. So it's going to be 3 squared, and 3 squared is 9. Next we have 3 to the 1st, that's 3. 3 to the 0 power is 1. 3 to the -1 is going to be 1/3. 3 to the -2 is going to be 1/9. For those of you who are doing any calculating, the decimal, it's going to be 0.3. Either of those is fine. It's probably better to get the decimal in these cases because it'll be easier to know where to plot the point as well. So let's look at what this graph is going to look like. So it's 2, 9, 1, 3, 0, 1. You have like 0.3, point, yada yada. So your graph is going to make sure it looks like a curve. And just make sure you don't cross this y-axis. So your graph shouldn't be like this. It should be above that y-axis. And again, we're going to skip 2. And again, we would know this was growth because the thing going to the power is greater than 1. As long as that number going to the power is greater than 1, it would be considered growth. Let's look at number 3, our third graph here. For this graph, it's 4 to the x. So that means you should know immediately this is growth. And again, if I'm putting in values, I'm going to show the middle for this one. And you can just put x, y. You don't have to show the middle piece. And pick these same values. And I have a half. And then it's 4 squared. 4 squared is 16. And half of that is going to be 8. Half of 4 to the 1st. 4 to the 1st is 4. And half of that is 2. Half of 4 to the 0, that's going to be a half, or 0.5. Half of 4 to the -1, half of 4 to the -1. So remember, 4 to the -1, I'm just going to do it down here, I don't have space up there. It's going to be 1/2 times 1 over 4. Because the negative exponent is going to the denominator. Be 1/8. 1/8 is 0.125. And then the next one is going to be 1/2 times 1/16, which means this is going to be 1 over 32. No idea what that is as a decimal, but it's really small. So now let's find our points. We have 2, 8, 1, 2, 0, 1.5. I'm sorry, 0.5. Negative 0.25, etc. Something like that. Missed the point. Let me fix that. And it's going to something like that. All right, for number 4, this one would be a decay function because the number to the power is less than 1. Again, as long as the numerator is smaller than the denominator, we know it's less than 1. So this is decay. And let's look at some values. Again, I'm going to stick with the same. And this time it's 5 2/3 to the x. All right, 5 times 2/3 to the second, 5 times 2/3 to the first, to the 0. All right, so again, you can just put this completely in the calculator. I'm going to show a little bit more work for it just so you can see where I'm getting these values. But when we square the 2/3, we're going to have 5 times 4/9. We're going to have 5 times 2/3 for the next one. All right, so that's going to be 20/9. This next one's going to be 10/3. And this next one's going to be 5. Because 2/3 to the 0 is 1. For the next one, it'll be 5. With a -1, basically these are going to switch places, so it'll be 3/2. So it'll be 15/2. And this will be 5 times 9/4. So it'll be 45/4. Okay, I'm just going to get some roundabout decimals for these. For the first one, it's going to be 2.2. This next one's going to be 3.3. This is 5. 15 divided by 2 is 7.5. And this is 11.25. All right, so let's plot these points. Now, because it's times 5, you know, it's not just 2/3, so it's a little different, but it'll be 2, 2.2, 3, I'm sorry, 1, 3.3, 0, 7, I'm sorry, 0, 5, -1, and -2. This will be 11, so something like that, etc. So, oops, shouldn't be crossing that line. Something like that, right above the line. All right, so that's pretty much what the graph should look like. You can pause it and try the 5th graph. I'll make a little table and put those up, but see if you guys can try to get some values for this one. All right, so once I plugged into the formula, these are my values, and this is what I have. So I'm just going to do the graph with you. I have 2, -12. So I'm going to add a dash or 2, so somewhere down there. 1, -6. 0, -3. -1.5. So basically, this graph will look something like this. Now, even though it's underneath like this, etc., you would still consider this growth because the thing that's in the parentheses is greater than 1. All right, so let's move on. The next page, I have a few more examples, just asking you some questions about some pre-established graphs and etc. This one says identify the following. Is it growth or decay? This would be growth. The domain, remember the domain are the x values. And for the domain, it'll be negative infinity to positive infinity. Because x can be anything, there's no restrictions on x. For y, it's going to go from, it's going to be open at 0, because this can't be 0, and it's going to be to positive infinity, because you can't include positive infinity, can't be closed off. And then the asymptote is going to be the x-axis, or y equals 0. And the y-intercept is this point here, is where it touches the y-axis. So it's going to be 0, 3. Again, in case you do not remember, when it comes to these intervals, this is when it's a closed circle. And this is going to be when it's an open circle. It's going to be like the parentheses, closed circle, or the brackets. And you can never have a closed circle at infinity, because infinity is like, not a specific value. So that's why it's parentheses versus the bracket. Second example, ask you whether it's growth or decay. Again, you don't worry about this negative piece. You really just look at what's to the power. This is growth. The domain is going to be all real numbers. You just put the big R, or again, negative infinity to positive infinity. The range is going to be, if you look at it, the graph is still not crossing this x-axis, but we're not going to say from 0 to but we're going to say from 0 to, it's not positive infinity, it's negative infinity. So therefore we would write it, you always write the minimum first. So we would write it as negative infinity to 0. And again, both of those are parentheses. And then the asymptote is y equals 0, which is also the x-axis, because it won't cross that. And the y-intercept, here we go, it's 0, negative 2. Last problem like this. The third one here, it says identify the following. Is this growth or decay? For this one, this is going to be decay. The number to the power is less than 1. It also should be pretty obvious because it shows like a decline, like a steady decline. If it looks like it's coming downhill, decaying, getting less, it's decay. And then domain is going to be, again, all real numbers. And again, if you wrote it this way, negative infinity to positive. 0 to positive infinity. And the asymptote is going to be the x-axis. All right. I think I have 1 or 2 more questions dealing with the graphs. You guys, this next little group, you can try these on your own. This next little group here is just trying to match them up. I'll post those answers. And then at the bottom here, there's just some more word problems. So try some more word problems. Again, our final quiz will be this Friday, guys. Have a great day.